Hello everyone, welcome to Eco Wisdom by Dr. Aditi. Today's topic is Indifference Curve, meaning and properties. Indifference curve is one of the hot favorites of the paper setters and examiners, especially for the college and university exams, BA BCom exams. This question is generally very frequently asked. Also for other competitive exams like civil services exams or net set exams, this kind of question is like the objective questions or MCQ based questions on this particular topic are quite common. So let's understand meaning and properties of indifference curve. So what is indifference curve? Indifference curve is a locus of all points which show different combinations of two goods or two commodities which provide same level of satisfaction. So for example, there is an indifference curve, and each and every point on that indifference curve will basically show same level of satisfaction. I'll give you a very easy example. So understand that there are two fruits. There is banana and there is apples. So on one of the points on a particular indifference curve, suppose there are 2 apples and 4 bananas, and a person or the consumer is getting XYZ level of satisfaction. Now on the other point on the same indifference curve, again there will be some other combination of banana and apple which will also give the consumer same level of satisfaction, which is XYZ level of satisfaction. So that is how indifference curve in theory takes place. So now one by one, let's look at all the properties of indifference curve, and there are also diagrams which depict these properties in a very easy manner. So let's begin. So we have just covered the meaning of indifference curve, and we are about to begin the properties of indifference curve. So the first one here is indifference curve is downward sloping from left to right. So indifference curve has a negative slope basically. So why this negative slope, or why is it downward sloping from left to right? So assume that we are at this particular point on an indifference curve where this much is the y, good y in a combination, and this much is the x. Say I'll just like drop a perpendicular, which is not very perfect, but it is for an understanding. So x is only this much. Now we have to move to this particular point. This is like another combination wherein the x is increased in this particular combination, whereas y has dropped down. So what we are trying to understand here is, if we want to increase the quantity of a particular commodity, then we have to reduce the quantity of another commodity. So the two commodities, or the movement of these two commodities is happening in opposite direction, hence it is downward sloping from left to right, or it has a negative slope. Do you remember how law of demand works? So if there is a sudden rise in price of a particular commodity, other things being equal, then the quantity demanded will go down. So price and quantity are again moving in two opposite directions. So there also, in case of demand curve, the direction is downward sloping from left to right. So it has again a negative slope. So the same logic is applicable over here. Now let's move on to the second quality or the property, which is higher the indifference curve, higher will be the satisfaction. So in the particular diagram, there is IC1, IC2, IC3. So whenever there are multiple indifference curves in a diagram, it is known as indifference map. So here is the indifference map in which IC1 is the indifference curve which say shows satisfaction level of XYZ. Then there is IC2 which is at the right side of IC1 or which is above the IC1. So IC2, let's assume it shows the XYZ2 or whatever, like that satisfaction. And IC3, it is at the rightmost point in the diagram, so it shows XYZ4. Okay, so what we are trying to understand here is IC2 is showing more level of satisfaction than IC1, and IC3 shows the highest amount of satisfaction. So any point here will show same XYZ level of satisfaction. Any point on IC2 will show same XYZ2. Any point on IC3 will show same, which is XYZ4 level of satisfaction. So higher the indifference curve, higher will be the satisfaction. Now there is another one, the third property, that indifference curves do not intersect each other. Now it is very easy and it is very obvious that, as we have just now discussed, that two indifference curves show different level of satisfaction. Now here what is happening, these two indifference curves are intersecting each other at this particular point. Whenever there is a point of intersection, that means that particular point is common point on both the curves. So technically here it means that that particular point shows a common level of satisfaction which is present on both the indifference curves. So it is equal to, that point is the same or the constant satisfaction on both. But in reality that doesn't happen, because this indifference curve will show a particular level of satisfaction, this will show another particular level of satisfaction. Assume there are like two indifference curves, this indifference curve and there is other indifference curve which is very close to this particular indifference curve, but still this which is at the right side or which is higher will always show higher level of satisfaction than this. So there cannot be a point of intersection or there cannot be a common point when we talk about indifference curves. Then there is second last or fourth property, which is indifference curves do not touch any of the axis. So here x-axis, y-axis, again on x-axis we have good x, on y-axis we have good y, and there is these two IC indifference curves. Now if we focus on this particular indifference curve and drop a perpendicular, so it shows that this particular indifference curve is only concerned about this good x. So it only talks about one commodity, which is commodity x, and here it talks about commodity y, this particular indifference curve. So both of them discuss only one commodity, which is not what indifference curve is. Indifference curve is what? It is a locus of points which show combination of two goods. So two goods is a necessary condition over here which is not getting fulfilled in this particular diagram. So indifference curve cannot touch any of the axis. Now let's move on to the last property, that indifference curves are convex to the origin. Now in the diagram you can see the shape of indifference curve is quite like self-explanatory, that it is convex. Now here we can see this particular shape can be seen as concave, but it is not concave, rather it is convex. And why is it so? So the reason for it is principle of diminishing marginal rate of substitution. Now what is diminishing marginal rate of substitution? So as a consumer substitutes one good for another, so the rate at which they are willing to make that substitution decreases. Now here is a table we have combination, then there is good X, good Y, and MRS, which is marginal rate of substitution. Now under combination A, we have one quantity of commodity or good X and 10 quantities or units of commodity Y. Then this is suppose the original combination to begin with. Now there is another combination which is B combination. Now here the commodity X is being increased. The units of commodity X are being increased. So 1 is becoming 2. And for that 10 is becoming 5. So there is a reduction naturally. We have seen this before, that why it is downward sloping. So when one is increasing, the other has to decrease. So that is happening. So what is the marginal rate of substitution? So 10 is becoming like 5 now. So 5. Now again we have to increase commodity X. So 2 becomes 3. And 5 is becoming 2. So we are reducing this good Y. Earlier it was 5. Now it is 2. So what is the difference? 3. Then again same thing under combination D. It is becoming 4. It is increasing, it is decreasing. So 2 minus 1, 1. So what is the trend over here? That it is 5. Then it is becoming 3. And then again it is going down, which is 1. That itself shows diminishing marginal rate of substitution. And this downward or diminishing trend in itself is a reason why indifference curve is convex to the origin. So we have just now finished covering the properties of indifference curve. We have also seen the diagrammatic explanation and the logical explanation why the properties are so. So I urge that all of you practice the diagrams many times before you appear for your exams. Also, if you want any other topic, if you feel that you need explanation or revision of a particular topic, then do write in comments. And watch the complete video, share it with your friends, and like the video. Also, don't forget to subscribe to my YouTube channel, and stay tuned for more such videos. Thank you.